Alrighty, Albert. Are you ready? One-on-one tutoring right here because no one else decided to come. Unless they're all in the back. So, this is going to be really quick. Really quick. So yesterday, geez Louise. Okay, so now we have 2 people in the class. Makes it look a little better. So this is going to be very quick. Yesterday we went over proportions, right? Proportions, if we remember, was setting up 2 ratios. And the word problems, something was missing. And we had to find it, right? And we would designate this whole top row as something. Let's say dollars, right? And we would designate this whole bottom row something else, like food, right? For every $4, you get 3 pieces of candy. How many candies would you get for $6? So this is what we were doing yesterday, was proportions. We were setting it up. Then we were cross-multiplying, whatever that answer was, we were dividing, and then we were finding x. So what is 3 times 6? 18. 6, 12, 18. You then divide 18 by 4. What's 18 divided by 4? And yes, you are allowed to use a calculator. It's 4.5. Guess what? For $6, you get 4.5 pieces of candy. Right? You weren't here yesterday, so obviously you don't know. So, we were doing this yesterday, right? The hardest part was setting it up. Setting it up. Knowing where your x should go, knowing what numbers was given, what the rows represented. That was the setup. Doing the cross multiplication, then dividing was just the math to find the missing piece. But setting it up is the most important part. Today, we're doing percent proportions, which is literally almost the same thing. Almost the same thing. Except for something a little different. Now, you're not just dealing with numbers. Now you're dealing with one of those numbers. That's not it. Now you're dealing with one of those numbers with a, oh my gosh, with a percent. There it goes. So you're dealing with word problems and we're dealing with percents now. Okay, I should have put the other one, so I put this one up. This was the first example that we have to do. At a restaurant, Janice's bill is $20. She gives the waiter a tip of $3, which is 15% of her bill. Identify the base, part, and rate in this situation. So, the difference between traditional proportion problems and percent proportions is percent proportions has its designated spot for these numbers. It looks like this. Your part over base and your rate over 100, always. This right here, you guys, you have to memorize. If you're ever given a word problem and it has a percent in it, you want to identify your part, your base, your rate, and your 100 over 100. It's always going to be over 100. So you ask, what is the part, base, and rate? What does all this mean? Quite simple, really. The easiest one is your rate. Your rate is always the percent within the word problem. So whatever your percent is, you just get it and put it there, right? Your base, you want to think of it as the total, whatever the thing is, right? The car cost $13,000. You pay $4,000 up front. The base was the total amount of the car, which was the $13,000, right? That's what base is, the total. And the part is exactly the opposite. It's the remaining piece. It's the piece of the base. It's the part of the base, pretty much. So how much did you pay of the $13,000 car? $4,000? That's the part. So you put the $4,000 in there. That's just in that example that I'm saying at the top of my head.
Is that how you buy cars for real?
No.
No?
That's how you find the part, base, or rate. Depends on what you're looking for, right? Like if using that same example, you see a car for $13,000. They tell you, hey, you don't have to pay it all. Just pay $4,000. And you ask yourself, that $4,000, what is the percent that I'm paying up front? How much is that $4,000 out of the $13,000 in percent? That's why we use this, right? But it all depends on what number is missing, right? But right now we're not really looking for numbers yet. All we're looking at is our spots. All we're looking at is the part must go over the base and the rate must always go over 100. So, looking at this example, at a restaurant, Janice's bill is $20. She gives the waiter a tip of $3, which is 15% of her bill. Identify the base, part, and rate, okay? We're not looking for a number. They gave us all of it. All they want us to do is identify the part, base, and rate. So you tell me, you guys. You tell me, what's my rate? What's my rate? 15%. The 15%, right? Rate is always the percent. That's the easy one. Now tell me, what's my base?
Your base is 20.
Because that's the total bill, right?
Yeah.
20. What's my part? Because that's the amount of money you left, right? You have officially identified the part, base, and rate. And guess what? Percent is always out of 100. It's always out of 100, right? That's all we had to do here was identify. So, this first part of your practice problems, the whole first part, literally 1 through 10, that's all you're doing is identifying the part, base, and rate. Because it's important to identify it correctly. It's really important that we identify our part, base, and rate. If you accidentally switch these, which a lot of students do, they put the 20 up there and the 3 down below, you're wrong. You're wrong, okay? It must be the other way. But of course, that's just identifying the part, base, and rate. All we're doing is identifying.
Later on, we have to do something with those numbers, right?
Later on, as in right now,
Right now?
you must also know how to solve problems like these. At a plant that manufactures lighting fixtures, it is expected that about 2% of the fixtures assembled each day will have some type of defect. If 900 fixtures are completed in one day, how many are expected to be defective? So, just like proportions, one number is missing. That's your X. It's your job to arrange it in its designated spots so that we could use proportions to solve. So, let's do that. We saw this percent, right? That means we know we have a percent problem in our hands, which means you must think of part base rate over 100. Always. Always think of part over base equals rate over 100 if you ever see a word problem with a percent in it, okay? Always. So if you have in your head, oh man, percent, no, part base, rate over 100. Okay, let's fill it in. Part base rate over 100. This is my formula. Let's do that using all of this right there. What is given? Well, do this, you guys. Always do this. We always know the rate is over 100. Okay? Always put the 100 there. That's always going to be over 100. Tell me, what else is given? Are we given the rate? Are we given the part? Are we given the base? You tell me. 2%. Easy. Rate is always percent. You're always going to get that. And if you don't see a percent, guess what? That's your X. They want to find the percent, right? But not in this case. In this case, we're given the percent. Cool. The hardest part is knowing what your base and rate is, or base and part is. You don't know where the other numbers should go. Well, you do know, but it's difficult for a lot of students. But through practice, you'll get it. What's the other number that's given?
900.
Where should that go?
Base.
Why?
Because it's the larger number.
It's the only other number.
Oh, yeah.
So you don't know. You don't know whether 900 is part or base unless you read. If we read, we see if 900 fixtures are completed in one day. So in one day you make 900, that's the total, right? They are asking how many are expected to be defective. So out of the 900, how many are messed up, right? So they want to know the part. That's what they want to know. They want to know if 900 equals 100, how many lighting fixtures are defective? How much is 2% of 900? That's why we set it up like that.
So you got to divide 2 by 900.
No, you use proportions. Cross multiply, then divide. Huh? The multiplying? You multiply your cross sections. So 900 times 2, right? What, like this? Yeah, it doesn't matter. 900 times 2, 2 times 900, same thing. So 2 times 900 is what? Yep, 1800, right? What is 1800 divided by 100?
18.
So, just have to make sure. 18 lighting fixtures, if a company makes 900, they know that 18 will come out defective. All because they know 2% are always defective. So it's important to have this in your heads at all times. Part base equals rate over 100. And to know what is given. Either you're given the rate and the base and you're looking for the part, or you're given the part and the base and you're looking for the rate, or you're given the part and the rate and you're looking for the base. 100 will always be there, 100. That is percent proportions. It is the same thing. Cross multiply, then divide, same thing. The only difference is that now you have to get your numbers and put it precisely in its designated spot. That's important. Make sense? And like I said, in this worksheet, the first part, all you're doing is writing out, you're just identifying it. You're just writing out your answers like this. You're given all the numbers on this first part. You just have to practice putting it in the right spot. Okay?